A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking through some repository logs yesterday, and it hit me that we are basically living in the digital equivalent of leaving our house keys taped to the front door. We spend all this time building these incredibly complex, multi-layered security perimeters, firewalls, zero-trust networks, biometric scanners, and then we just hand out static strings of text that never expire, stick them in a text file, and call it a day. It is the secret zero paradox. We use secrets to protect our most sensitive data, but the keys themselves are the weakest link in the entire chain.
It is the ultimate paradox of modern engineering, corn. We have moved toward these incredibly robust zero-trust architectures for humans, where you have to jump through 3 hoops, verify a push notification, and scan your thumbprint just to check your work email. But for our software services, the things that actually move the data and run the business, we are still essentially using the equivalent of a sticky note under the keyboard. Today's prompt from Daniel is about exactly that, or rather, the painful transition away from it. He is asking about the downsides of application programming interface keys and whether there are smarter, non-interactive alternatives to this whole secret management grind.
It is a timely question, especially since Daniel is deep in the automation world, where these keys are the lifeblood of every script. But the landscape has shifted underneath us quite violently. In fact, just today, March 23rd, 26, security researchers at Sonatype identified 2 malicious packages on the NPM registry. They are called SPX-mask and touch-ADV. Their whole purpose is to sit quietly on a developer workstation and exfiltrate shell profiles and keys. It is like a digital vacuum for credentials. If you have your AWS keys or your OpenAI token sitting in your bash profile or a .env file, they are gone before you even realize you installed a bad dependency.
That is the perfect, albeit terrifying, example of why the old way is failing. My name is Herman Poppleberry, and I have been diving into the latest GitGuardian State of Secret Sprawl report for 2026, which just came out on March 17th. The numbers are staggering. In 2025 alone, they found over 29 million new secrets leaked on public GitHub. That is a 34% increase year over year. We are not getting better at this. We are actually getting significantly worse as our tools get more powerful and our development cycles get faster.
Well, that is the irony, isn't it? We have these AI assistants that are supposed to make us 10 times more productive, but they seem to be 10 times more productive at leaking our credentials too. I saw a stat in that same report saying that commits made using tools like Claude Code have a secret leak rate of 3.2%. Compare that to the baseline for human-only commits, which is about 1.5%. The AI is literally doubling the risk. It turns out that when you ask an AI to write a quick integration, its first instinct is to just hardcode the secret, because that is what it saw in a 1,000-stack overflow post from 10 years ago. It doesn't know about your organization's security policy. It just wants the code to run.
The problem is even deeper with new standards like the Model Context Protocol, or MCP. It was designed to help AI models communicate with local applications and data sources, which is brilliant for productivity. But in its first full year of adoption, we have already seen over 24,000 unique secrets exposed because the initial documentation and community examples often recommended hard-coding credentials in configuration files just to get the connection working. It is the classic struggle of developer experience versus security. If the Getting Started guide tells you to paste your key into a JSON file, that is exactly what people are going to do.
It is the path of least resistance. If I am a developer and I want to see if a new tool works, I am going to copy and paste that key into my .env file because it takes 2 seconds. Setting up a proper identity federation takes 20 minutes and a degree in cloud IAM. But we are reaching a breaking point. If 64% of secrets leaked back in 2022 are still valid and unrevoked today, in March of 2026, we are building a massive mountain of technical debt that is actually just a mountain of live grenades. We are essentially leaving a trail of permanent access keys across the internet.
That is why the industry is moving toward what we call non-human identity management, or NH. We need to stop thinking about secrets as static strings and start thinking about machine intent. The core issue Daniel pointed out is that these keys are single factor. If I have your key, I am you. There is no second factor for a script running in a container at 3 in the morning. NHI is about moving from what you know, which is the secret string, to who you are and where you are running.
So if we are moving away from the secret management grind, the tedious copy-pasting, and the constant fear of a leak.env file, what is the actual architectural shift? You mentioned machine intent. How does a server prove who it is without a password? Because at some point, don't you always run back into that secret zero problem where you need a key to get the key?
That is the hurdle everyone trips over. But the most robust alternative right now for anyone working in the cloud is Workload Identity Federation, or WIFF. Instead of giving your application a long-lived secret key to talk to another service, you give it a way to prove its identity through a trusted third party. Usually, this involves exchanging a short-lived OpenID Connect token, or OIDC token, for temporary cloud-native permissions.
I like the idea of short-lived tokens, but walk me through the mechanics. If I am running a service on a virtual machine and it needs to talk to a database, how does it get that token without me having to hardcode a different secret to get the first secret?
That is the beauty of the cloud provider's role here. In a Workload Identity Federation setup, the environment itself provides the identity. If you are running on a major cloud provider like AWS or Google Cloud, that instance has a cryptographically signed identity document provided by the metadata service. This service is only accessible from within that specific environment. Your application takes that document, sends it to the identity provider, and says, I am this specific instance running this specific code in this specific VPC, give me a token for the database. The identity provider verifies the document and issues a token that might only be valid for 10 or 15 minutes. There is no secret for a developer to copy-paste, and there is nothing for a malicious NPM package like SBX-mask to steal from your shell profile that would be useful for more than a few minutes.
It sounds like we are finally applying the principle of least privilege in a way that is actually automated. But what about the folks who aren't just in one cloud? A lot of Daniel's work involves hybrid environments, or local dev machines talking to various services. Does Workload Identity Federation work when you are hopping across different platforms or running on-prem?
That is where things like SPIFFE come in. SPIFFF, which is spelled SPIFFF, and stands for Secure Production Identity Framework for Everyone, is a set of open source standards for exactly this. It provides a platform-agnostic way to issue identities to workloads. The companion tool is SPIRE, spelled SPIRE, which is the runtime environment that actually does the heavy lifting. It is a cloud-native computing foundation project, and it is becoming the gold standard for non-human identity.
I remember seeing a headline about a security patch for SPIRE recently. Was that related to this?
It was. On March 3, 2026, they released version 1.14.2 specifically to patch some critical vulnerabilities related to server-side request forgery and CPU exhaustion. It just goes to show that even the tools we use to secure our identities need constant auditing. But the core concept of SPIRE is fascinating. It uses what are called SVIDs, or SPIFF-FE verifiable identity documents. These are basically short-lived, cryptographically signed documents, often in the form of an X509 certificate.
And how does SPIRE know it is talking to the right service? Is it looking at the process ID or something more robust? Because if it is just a process ID, couldn't a malicious script just spoof that?
It is much more robust than that. It uses what they call workload attestation. When a service starts up and asks for an identity, the SPIRE agent looks at the runtime attributes. It checks things like the Linux kernel metadata, the container image hash, the Kubernetes namespace, or even the binary hash on the disk. It is basically saying, I will give you this identity not because you have a password, but because I can see exactly what you are, what code you are running, and where you are running it. This allows for mutual transport layer security, or MTLS, between services without a human ever having to touch a certificate or a key. It is the ultimate, no interactive alternative Daniel was asking about.
That is a massive shift from the copy-paste culture. It takes the burden off the developer and puts it on the infrastructure. But I can hear the pushback already. Developers love the simplicity of a key. If I'm using an AI coding assistant and it says, hey, just put your OpenAI key here to get started, I'm going to do it because I want to see results. Are we seeing these non-human identity frameworks actually getting integrated into the tools we use every day? Or is this still just for high-end enterprise platforms?
We are starting to see the shift, but the friction is still there. According to the GitGuardian report, internal repositories are 6 times more likely to have hard-coded secrets than public ones. That is a huge red flag. People assume that because a repo is private, the perimeter will protect them. But as we saw with the Tycoon two-factor authentication infrastructure seizure by Europol on March 4th, even multi-factor authentication for humans is being bypassed at scale using adversary in the middle techniques. If the human gate is cracking, the machine gate needs to be even stronger. We can't rely on internal being synonymous with safe anymore.
It feels like we are in a race. On one side, you have the ease of use of AI tools that are accidentally encouraging bad habits, and on the other, you have these sophisticated identity frameworks that are still a bit of a hurdle for the average developer. We actually touched on the risks of AI-driven development back in episode 1070 when we discussed the agentic secret gap. It is wild how much that gap has widened in just a year and a half. Back then, we were worried about AI suggesting bad code. Now we are worried about AI agents autonomously committing secrets to repos at a rate humans can't even audit.
The agentic side of this is the real wild card. When you have an AI agent like Claude Code or a specialized command line interface making commits for you, it is operating at a speed where a human can't realistically audit every line for a leaked token before it hits the repo. We need the security to be baked into the environment itself. This is why the National Institute of Standards and Technology, or NIST, updated their special publication 863-4 recently. They are now mandating that if you must use service account passwords, they have to be at least 32 characters long and generated by secure random number generators. But more importantly, they are strongly pushing everyone toward passwordless machine identities.
32 characters. That is a lot of random text to manage if you are still doing it manually. I suppose that is where dynamic secrets come into play. I have seen tools like HashiCorp Vault or in physical moving in that direction. The idea is that you don't even have a static key to leak, because the system generates a one-time key for you on the fly.
Dynamic secrets are essentially just-in-time credentials. If your application needs to talk to a database, it doesn't have a username and password in its config. Instead, it asks the Vault for access. The Vault then goes to the database, creates a temporary user with the exact permissions needed for that specific task, and hands those credentials to the app. Those credentials might only last for 5 minutes. If a hacker steals them, they are useless by the time they try to use them. It solves the secret zero problem by ensuring that even if you have to use a key to get a key, the second key is so short-lived that the blast radius of a leak is almost zero.
It is like the Mission Impossible, messages that self-destruct after 5 seconds. But for a developer, does this change the workflow? Do I still have to write code to fetch these secrets, or is it handled by a sidecar or some other infrastructure layer? Because if I have to write 50 lines of boilerplate just to connect to a database, I'm going to go back to my .nv file.
It is increasingly handled by the infrastructure. You can use sidecars in Kubernetes that automatically inject these temporary secrets into the application's memory space or as a local file that the app thinks is a standard config. The app doesn't even know the secret is rotating every few minutes. This completely eliminates the need for a developer to ever see the production secret, let alone copy and paste it. It removes the tedious grind. Daniel mentioned because the rotation and management are entirely offloaded to the platform.
Which is the dream, really. I want to live in a world where I never have to look at a base 64 encoded string ever again. But let's talk about the reality for someone like Daniel or any of our listeners who are managing a growing list of API keys for various AI services and automation tools. If they wanted to start moving toward this non-human identity model today, where should they actually start? Because you can't just flip a switch and have SPIRE running across your whole stack by Monday morning.
The first step is an audit, but a specific kind of audit. You need to look at your continuous integration and continuous deployment pipelines, your CI/CD. That is where the most dangerous secrets live because they often have high-level permissions to deploy code or access production data. Check if your cloud provider supports OIDC for your CI/CD runner. For example, if you are using GitHub Actions to deploy to Amazon Web Services or Google Cloud, you should stop using static IAM keys immediately. Use Workload Identity Federation to let GitHub prove its identity to the cloud provider directly.
That is a huge win right there. No more secrets stored in the GitHub repository settings. If someone compromises your GitHub account or a repository, they still don't have a static key they can just walk away with. They would have to compromise the entire OIDC handshake in real time.
And the second step is to look at how you are using AI coding assistance. If you are using a tool that has access to your terminal or your file system, like Claude Code, you need to be extremely careful about what is in your local environment variables. As we mentioned with the SPX-mask malware discovered today, your local machine is now a primary target for credential harvesting. Moving your secrets into a local vault or using the tool that fetches them only when needed can prevent a simple malicious NPM package from ruining your whole month. 73% of organizations still rely on static API keys despite having zero trust on their roadmaps. Don't be part of that 73%.
It is funny how we have come full circle. We started with no security, then we moved to passwords, then API keys, and now we are basically saying that the best way to be secure is to not have a key at all. It is about proving who you are through your context and your behavior rather than what you know. It is a more organic, albeit more technical, way of thinking about identity.
It is the only way to scale. We are moving toward a world where the number of non-human identities vastly outnumbers the human ones. If we try to manage them all with the same manual processes we used for human passwords in the 90s, we are doomed. The SPY Cloud Identity Exposure Report from March 19th showed that 18.1 million exposed API keys and tokens were recaptured just in 2025. That is a massive amount of exposure that static keys simply cannot handle.
It makes me wonder if we will eventually reach a point where the concept of a secret is considered a legacy security flaw. Like, oh, you are still using secrets. That is so 2024. We just use cryptographically verified intent for everything now. It sounds futuristic, but with the rate of leaks we are seeing, it might be a necessity sooner than we think.
We are getting there. The shift from secret management to non-human identity management is really a shift from static trust to dynamic verification. It is more work to set up initially, but it removes that tedious grind Daniel mentioned. Once the pipes are laid, you don't have to keep carrying buckets of water. The identity just flows where it needs to go, and it expires the moment it is no longer needed.
I think that is the key takeaway for a lot of people. It feels like more work up front because you have to learn these new frameworks like SPIFFE or set up Workload Identity Federation. But the long-term payoff is that you never have to deal with a rotated key breaking your production environment at 2 in the morning because you forgot to update one config file in a forgotten microservice. The system handles the rotation for you.
And that is the real beauty of automation. True automation shouldn't just be about doing things faster, it should be about making things more resilient. If your security relies on a human being correctly copy-pasting a string of characters every 90 days, that is not a secure system. That is just a countdown to a mistake. And as we've seen, those mistakes are becoming increasingly common and increasingly costly.
A mistake that, as we saw, 64% of the time won't even be fixed for 4 years. That stat really stuck with me. If you leaked a key in 2022, there is a better than even chance it is still out there, just waiting for someone to find it. It is like leaving a spare key under the mat of a house you moved out of years ago, but that key still works on your new house because you used the same lock.
It is actually worse because that key might give access to your entire cloud infrastructure. The permanence of leaked secrets is one of the biggest arguments for moving to short-lived dynamic credentials. If a key is only valid for 5 minutes, the window for abuse is almost non-existent. Even if a malicious package steals it, by the time it exfiltrates the data to a command and control server, the token has already expired.
It changes the whole math of a data breach. Instead of a catastrophic event that compromises your entire history, it becomes a contained incident that is automatically mitigated by the clock. I think we're going to see a lot more focus on this as we move through 2026, especially as these AI tools become more autonomous. If an AI agent is going to be spinning up infrastructure and deploying code on our behalf, it needs to be able to do that without us handing it the keys to the kingdom.
We did a deep dive on secrets management back in episode 1229, talking about moving beyond the .n file. If you are listening to this and feeling like you are drowning in API keys, that might be a good one to revisit for the foundational stuff. But the conversation today about non-human identity is really the next level of that. It is not just about where you store the key, it is about whether you need the key at all.
I think we have given Daniel and everyone else a lot to chew on. The move to passwordless machine identity is clearly the way forward, even if the transition period is a bit messy. It is definitely better than the alternative of just waiting for the next malicious NPM package to clean out your workstation. It is about being proactive rather than reactive.
It is a journey for sure, but when you see the results, the reduction in manual toil and the massive increase in security posture, it is hard to argue with the direction the industry is heading. We are moving away from secrets as a liability and toward identity as a service.
Well, I, for one, am looking forward to the day when my terminal doesn't feel like a liability. We should probably wrap this up before I start getting paranoid and changing all my passwords again, even though we just established that passwords are the problem.
Probably a good idea. We have covered a lot of ground today, from the sprawl of leaked secrets to the sophisticated frameworks like SPIFFE and SPIRE that are trying to solve it. It is a complex topic, but a vital one for anyone building in the modern era.
It is a lot, but it is necessary. Thanks for the deep dive, Herman. You really have been waiting to nerd out on SVIDs and workload attestation, haven't you?
Guilty as charged. There is something satisfying about a well-architected identity system that just works without human intervention. It is the peak of engineering.
I will take your word for it. Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power the generation of this show. Their serverless infrastructure is actually a great example of where these kinds of secure, short-lived identities are so critical.
If you are finding these deep dives helpful, we would love it if you could leave us a review on your favorite podcast app. It really does help other people find the show and keeps us going. We love hearing your feedback and your own weird prompts.
This has been My Weird Prompts. You can find our full archive and all the ways to subscribe at myweirdprompts.com.
We will see you next time.
Stay secure out there.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weirding.